push that rock here with some math. Let's ask questions about magnitude and direction of vectors. So what is the magnitude and direction of this vector? So the very first thing I do is get a visual representation of the vector. It's a two-dimensional vector because there's only two numbers here. And I use the traditional method of the Cartesian plane where we treat this as a horizontal distance and this is a vertical distance. So I'm going to go horizontally to the left 3 units, 1, 2, 3. And then I'm going to go up 3 square roots of 3. Well, we know the square root of 4 is 2. The square root of 1 is 1. So the square root of 3 is going to be closer to the square root of 4 of 2 than 1. And we've been using all semester about 1.7 as good approximation. Now, if I triple that, I'm tripling 17, essentially. So, 17 and 17 is going to be 34. And you add another 10 in is 44, and another 7, you're at 51. So about 5.1. So 3 square roots of 3 is about 5.1. So I go up about 5.1. 1, 2, 3, 4, 5.1. And I'm about right there. So, and then I'm going to draw this right here. And so we want to know how long is that, and we want to know what this angle is. So I'm going to use R for magnitude. So I'm going to represent R because I'm going to think of this as a radius. There's some circle that this point is on. And I'm going to use R as the magnitude and theta as the direction. Okay, and I could use a negative angle, but I think here using a positive is fine. And so, I could just kind of measure it and see what I think it is. This is not the most accurate method because, first of all, this is a machine-driven, computer age Cartesian plane I got here, but it looks like it could be 120 degrees or a little less. Okay, so the direction may be about 120 degrees or 2 pi thirds. We can get the radius or the magnitude very easily because we can think of some circle that's on here, and we know that negative 3 squared plus 3 square roots of 3 squared has to equal whatever the radius is squared. So negative 3 times negative 3 is 9. 3 times 3 is 9, and root 3 times root 3 is 3. Okay, so I have 3 9s here and 1 9 here. Well, if you have 3 somethings and you have 1 something, you put them together, how many somethings you got? You got 4 somethings, so this makes me have 4 9s. When I add this up, it's like having 3x plus an x gives you 4 x's. Now, when I take the square root of both sides, in order to get what r is, I get 2 times 3, which is 6. So another way to have done this is say, 3 times 9, and then add in 9, and then, you get 36, because 27 plus 9 is 36, and the square root of 36 is 6. So, but I was just trying to teach some number sense there. So this is a radius of 6. Now, let's think of cosine of theta. It's supposed to take the x coordinate and divide it by the radius, 6. So cosine would take this angle, whatever it is, and map it to negative 1/2. Oh, well, we know what that is. We know that cosine in quadrant 2 maps 120 degrees to negative 1/2, or it maps 2 pi third radians to a negative 1/2. So the direction is 2 pi thirds, and the magnitude is 6. So we answered the question. Now this happened to be a scalar multiple of a very convenient vector. Like another trick I could have done here is I could have said, well, I recognize the square root of 3 here. Let's factor out a 6. Why 6? Okay, let me get some scratch paper and do that. So I'm going to factor out from a negative 3 square roots of 3. I'm going to factor out a 6. So that means I'm doing a negative 3 divided by 6. Why 6? Well, it was the radius, remember. And then 3 root 3 over 6. So remember, factoring means dividing by. Okay, so if I put a 6 out here, 6 times this, the 6's cancel, and I'm back to negative 3. 6 times this, the 6's cancel, and I'm back to 3 root 3. So I haven't changed the vector any. I just created a scalar multiple. Now, let's reduce it. Okay, so that's negative 1/2. and this is root 3 because this goes down to that over 2. And I recognize this is from the unit circle, and it's on the unit circle when the angle is 2 pi thirds, and then I see, oh, it's just scaled up 6 units, so I know that r is equal to 6 and theta is equal to 2 pi third radians. Okay, so that's another way to have handled that problem. And I can do it that way because it happens to be a scalar multiple of a convenient vector. Okay, we have a scalar multiple of a convenient vector. What if it wasn't a convenient one? One I don't recognize. Okay, like this one. Okay, well, again, I'm going to draw a picture first. I'm going to go over the square root of 5. Well, square root of 4 is 2. So square root of 5 is just slightly past 2. And then I'm going to go down 2. 1, 2. And I'm going to draw a vector. So at the very least, I can estimate this angle here, you know? Just get out a protractor, make sure this lines up and everything, and then, you know, figure out what that is, you know, and maybe need to draw this out a little further so I can see where it's intersecting. But, you know, get out a protractor and just kind of estimate what you think it is. So, you know, maybe it's a negative 44 degrees or something, you know? So, you know, my estimate for this is a negative 44 degrees, okay? Well, what about the magnitude? Well, that's easy again. So we'll just picture a circle, you know, that this being a point on a circle, and we know that x squared plus y squared equals r squared. So I'm going to put the square root of 5 in here and square it. I'm going to put the negative 2 in here and square it. And square root of 5 squared is 5. And negative 2 times itself gives me positive 4. Remember, a negative times a negative is a positive. So I get 9 is equal to r squared. Oh, that was convenient. And then I take the square root of both sides, and I get the magnitude is 3. So I think the magnitude, another way to represent magnitude is with this double bar stuff, but I'm just using r. The magnitude is 3. So the magnitude is 3, and the direction is about negative 44 degrees. Now, what if I needed to express the direction in exact terms? In exact terms. Well, this is where your inverse trig would come into play. Let's use tangent because remember we graph tangent from negative pi halves to pi halves when we're looking at its inverse. So I'm going to say tangent of theta is equal to the y over the x. And now to undo tangent, you do the inverse operation, which is arctangent, okay? So I do arctan of theta on this side. And I do arctan of negative 2 over root 5 on this side. This undoes each other, and I just have theta is equal to arctan of negative 2 over square root of 5. And then this is the exact representation of this approximately negative 44 degree direction here. And if your engineer friend who's building the bridge and you're the mathematician reporting to him needs to know what this is exactly, well, he can type it into a computer and it will tell him exactly. He just needs to make sure his computer is in the correct mode. If he needs radians or degrees, he sets the mode and then he types this in and it tells him the exact. And you can even play it and see how good my estimate is. Put it in degree mode and see if it's a negative 44 degrees. Math made simple. It's some math.